For some of you, you might be interested in doing something like means and extremes or cross multiply. This comes from the algebra world, or the arithmetic world. If I want to know that two fractions are equal, I would say, is 1/2 equal to 3/6? I can reduce it down. So I've got a fraction, single fraction, equaling a single fraction. In arithmetic it says, if you then cross multiply, which means multiply down, you get 6, multiply up, you get 6. If 6 equals 6, then the two fractions are the same. Now, that works as long as you have a single fraction divided by a single fraction equaling a single fraction. That would not work for this problem because it's not a single fraction. But it would work for this one. So that would say, if I were going to use means and extremes, that would say -2 times x plus 1 is equal to -3 times x plus 4. That's what's so nice about means and extremes. Now I just solve. -2x minus 2 equals -3x minus 12. Add 3x to both sides. This says that x minus 2 equals minus 12. Add 2 to both sides, so that x equals -10. Now, it would work the same way if you would choose to multiply both sides by the common denominator. And if you look at what the LCD is just the product of those two denominators. So that's what the LCD is. So that if you took -2 over x plus 4 equals -3 over x plus 1. That's what I'm going to do with the next problem. And you multiply both sides by the common denominator. Oops, I'm going to move this over here. You notice this takes out the x minus plus 1. This takes out the x plus 4. And you're going to end up with -2 times x plus 1 equals -3 times x plus 4. And if you take a look, that's the same thing you got when we did means and extremes. And then you'll end up, of course, with the same answer. That works for both. So either way, I personally, when I'm doing a fraction equaling a fraction, that's probably the way I would do it, over multiplying through by common denominator. But it works both ways. And see, sometimes you think there's only one way to do a problem. No, there isn't. Usually a plan B. Multiplying both sides by the common denominator always works. You never have to worry about tricks, just complication. Now, if I take a look at this guy, and I can't use means and extremes. Now, I could. If I put, this is already a single fraction. If I put this over a common denominator, I could use means and extremes on it. I could do that. But I'm not. So I'm going to look at what the LCD is, and the LCD is just the product of those two things. So the LCD is going to be 2x plus 3 times x minus 1. So anytime I'm looking at a problem, and that problem has an equal sign, I can take the left-hand side of the problem. It's like basically having that scale with this being the measurement or the measurer, and I can take the right side of the problem because they are equal. Because of the equal sign in between, and then I can say to myself, whatever I do to the left, I can do to the right, as long as it remains in balance. Doesn't matter what I do, because the left-hand side is totally equal to the right-hand side. In this case, I'm going to multiply both sides by the LCD, which is 2x plus 3 times x minus 1. 2x plus 3 times x minus 1. Good news is it takes this whole denominator away, so he's going to be just a 1. This is going to be 2x plus 3 times x times x minus 1, and that's going to be multiplied times the first, because I'm using the distributive property. Two x plus 3 times x minus 1, and that's going to be multiplied times the second factor, or second term. And then this whole side on the other, then I have my equal sign. So once I've multiplied this through using the distributive property, then I have the equal sign. That denominator completely went, and it's equal to 1. Now, many times, for some of you, once you write this down, it's like you do it in your head. Here, your 2x plus the 2x plus 3's go. You're left with 1 times x minus 1 plus, here, your x minus 1 goes. You're left with 1 times 2x plus 3 equals 1. Now, do you have to put the 1 in? The answer is no, but it's there. Whether you see it or not, it's there. If that was a minus, it would make a difference, but since it's a plus, it doesn't. And that's because a plus 1 times x minus 1 is just x minus 1. A plus 1 times 2x plus 3 is just 2x plus 3 is equal to 1. Some of you are going to get, for a while, I'm going to put in a lot of steps. And then after a while, I'm going to start leaving them out. So when I start leaving them out and you have a question and you say, wait a minute, how did you get that? That's what you want to do. You want to stop me to do that. So 1x plus 2x is 3x. Minus 1 plus 3 is plus 2 equals 1. Three x equals, subtract 2 from both sides, or x is minus 1/3. Now what x cannot be is something which makes the denominator 0. That is the domain of the solution set. So if I come back over and I say, what is the domain? So what can x be? The denominator, I don't care what the numerator is. Denominator can't equal 0. And my LCD is 2x plus 3 times x minus 1. Can't be 0. Those are the denominators. Are there any denominators I have? This says that 2x plus 3 can't be 0. X minus 1 can't be 0. X can't be negative 3/2. X can't be 1, but it can be anything other than those two. And I got negative 1/3, so I should be fine. Domain. I think first question on your worksheet. Domain. What is the domain? Questions? Denominator can't be 0. Don't care what the numerator is. In this particular instance, if I go to the problem here at the top, x can't be what? Can't be, and x can't be negative 1. Could be anything other than those two, because it is the denominator that can't be 0. I don't care what the numerator is, but the denominator can't be 0.